So good morning all. Today we are starting with the unit number 4, that is polymorphism. In today's session we are going to cover the virtual base classes, what is meant by virtual base class and what is the importance and how to create it, that we are going to learn in today's session. Next we need to learn early binding and late binding to understand the virtual functions. So first of all we are going to understand early binding and late binding, and after this we are going to learn about the virtual functions. So let's start with the virtual base classes. Virtual base classes. The virtual base classes are used in virtual inheritance in a way of preventing multiple instances of a given class appearing in an inheritance when using multiple inheritance. Again I am repeating, virtual base classes are used in virtual inheritance in a way of preventing multiple instances of a given class appearing in an inheritance hierarchy when using multiple inheritance. Now let's understand this statement with the help of one example so that you will understand what is the meaning of multiple instances of a given class appearing in an inheritance hierarchy. Suppose this is the class A. Suppose this is the class A. This class will consist one method. Name of the method is display. Name of the method is display. From this class, you have created the class B and you have inherited it public, and you have created the class B from the class A. Just understand this diagram. Once you understand this diagram, automatically you will understand virtual base class. So just understand this diagram. You have created the class A, which consists the method display. From this you have created the class B, and which is publicly inherited. This class A is publicly inherited in class B. Next, I have created the class C from the class A. Again, this class A will publicly inherited in derived class C. So from class A, two classes are created, class B and class C. Class B and class C. Now, from this class B, class D is created. So this class D will inherit B in public. So B is publicly available at class D. Similarly, this class C will be publicly derived in class D. So this is the structure of the inheritance hierarchy. From class A, we have created class B and C, and from B and C, we have created the class D. And all the inheritance is having the public as access modifier. Now, what will happen? Just see. The problem is here. Let's create the object of class D. when you create the object of class D, like D object, suppose you have created the object of class D, D object. Now what is the problem? Let's see the problem. If we call object.display, if we call object.display, compiler will confused. Compiler will get confused. Why? Before going for why, I'm going to demonstrate this, how compiler will get confused. So I will open this code editor. This code is visible? Anyone?
Yes, sir.
Yes, sir.
Okay. So already we have created one project. Name of the project I have given virtual base class demo. And I'm going to demonstrate whatever we have learned in the diagram. Suppose this is the class A. In the class A, we have one method in public, that is void display. Inside this, I'm going to write one statement. To understand it, I'm going to write the statement inside display method in class A. Okay. So class A, inside I have public, in public area, I have created void display. Inside it, I have mentioned one statement inside display method in class A. And from this class A, I am going to create two classes, B and C. Class B, A. I'm not going to write inside this anything. I'm going to create class C, public A. Now I have created the two classes, class A and class B and C from class A, as we have seen in this diagram. Class A and class B and C we have derived from class A. Now I'm going to create the class D from B and C, public B, comma, public C, public B and public C. And now I'm going to create the object of D object. Okay, and now I'm going to compile the code. Just see this diagram again. This is our class A. Inside we have display method. From this we have derived two classes, B and C. And from this B and C we have derived class D. In the diagram you will see that this is the hierarchical inheritance. This part is multiple inheritance. This part belongs to multiple inheritance. Now, as I said earlier, if you call object or display, compiler will get confused. Just see in the code whether compiler will get confused or not. Call the display method by using the object dot Now I'm going to compile the code. Again I am repeating, I have created, just see how we have created this. This is our class A. From this we have created class B and C. And from B and C we have created the class D. D, public B and C. And inside main we have created the object of D, obj, and then we have called the method display, which is present inside the class A display. And now I'm going to compile the code and just see whether compiler will be successfully compile the code or it will give you a error message. At this point, at this line number 34, you will get the error message. What is the error message? Just see the error message. I'm going to read the error message. Error: request for member display is ambiguous. Request for member display is ambiguous. Ambiguous means confusion, uncertainty. Compiler don't understand here how to call the display. So it simply gives you the error message. Request for member display is ambiguous. Now see why this error. What is the reason why this error came? So this error came because we have two paths. Because we have two paths to reach display. From this class D to reach display, we have two paths. First one is this path. This D will be access display from this path also. Path A, path 1. You have inherited publicly display, so display will be available over here, and with the help of this path you can access this display. Similarly, this is the path 2. You have inherited class A publicly in class C and class C publicly in class D, so display is available from this path also. This is our part 2. And here is the problem. Compiler will get confused because there are two paths to reach to the display. Compiler will get confused because there are two paths to reach to display. From this path 1 and there is second path from this path 2. So that's why compiler simply gives you the ambiguity message, that is error message. So what is the solution for this? With the help of code, I am going to give you a solution. Just see. What is the solution for this? The solution for this is to make these classes B and C as a virtual classes. How to make this virtual? You have to add virtual public key. You have to inherit A in a B in virtual way. So you have to add this virtual keyword before the public A. Similarly, you have to add the virtual keyword before the public A in class C. So our class A becomes virtual and it is virtually inherited in B and C. And this is called as virtual class. This is called as virtual class. This class A is our virtual class and we have inherited this virtual class into B and C, and this is the way to inherit it. Once you do this, the compiler automatically find the path to achieve to the display. Now just let's see whether is there an error message or it will be executed properly. Just see, I'm going to compile the same code. Just what I have did here, I have made changes in the class B colon, I have added virtual keyword. Class C colon, I have added virtual keyword. That's it. So just save it, compile it. Now just see the message. There is no error message. There are 0 errors, 0 warnings. Okay, and I'm going to execute it. So this is the output of the program inside display method in class A. Inside display method in class A, and in the main the hello world message is present. It will be displayed over here. So this is how you have to create virtual base class. Now again, let's understand this with the help of PPT. So this is our class A. Before that, just understand when you require to have a virtual base class. Suppose this is the hierarchy. From class A, you have created class B, and from class B, you have created class D, and from class A, you have created class D, and from class C, you have created class C over here, and from class C, you have created class C. So in this structure, inheritance structure, you don't need to have a virtual class. Why? Because you don't have any ambiguity path in this structure. If your hybrid structure is like this, here you don't need to use virtual because there are only one path. The first path, this is our first path. You can inherit or you can access directly. There is no ambiguity. From class D, you can access class A's member, B's member, and class D members. Similarly, there is no ambiguity. From class E, you can access the members of C and members of A. There is single path to access the members. So no need to have a virtual class. No need to have a virtual base class in this structure. So next structure, suppose this is the class A. Your display method is present. You have created class B from class A, and you have created class C from A, and again you have created class D from B and C. So in this structure, you need to have a virtual base class. In this structure, you need to have a virtual base class, because from this class D, you can access the members of B and C. There is no ambiguity. There is only one path. But you are going to access the members of class A, for example, display method. There are two paths. You can access the display from this path also and from this path also. This is our path 1 and our path 2. So here it is, the ambiguity. In this case, you need to write virtual where multiple paths are being created. In a structure where you will have multiple paths, in that case, you need to write the virtual base class. But you don't need to write here. Don't write here. virtual. I will demonstrate this with the help of code. Suppose instead of writing virtual here, suppose you have mentioned virtual like this, virtual public B and virtual public C, and just see, compile the code. There is error message at the line number 34. What is the error message? Request for member display is ambiguous. So this will not be allowed. So don't write here. Write here. Write the virtual here. This is your virtual B, and you have to write the virtual in front of class C. And this is our virtual base class. It's not like that key you have to write virtual over here. No. Write virtual over here, virtual keyword in front of class B and in front of class C. Then it becomes virtually inherited, and compiler automatically take care about the path to call the members of the class A. And this problem happen in structure like this will be resolved using the virtual base class. Using the virtual base class. So next is early binding and late binding. So before going to start for early binding and late binding, I am going to explain one example so that you will understand what is meant by early binding and what is meant by late binding. So this is the chief present in his restaurant. What he will do, as per the menu card items, he is ready for preparing the atoms. So he already know which atoms to be prepared. He already know which atoms to be prepared. It is called as early binding. This analogy is called as early binding. This chip is already know which atoms to be prepared, which is present in the menu card. This is called as early binding. Now consider this chief is going to participate in a master chip competition. All these images I have taken from the internet. Take just for example, he is going to participate in master chip competition. What will happen now? He will prepare the atoms as per the judge's order. And now in this position, chief don't know anything about what to prepare. When judges gives the order, he will going to prepare that particular atom. But right now, or already he don't know which atom to be prepared. And this scenario is called as late binding. This scenario is known as late binding. Try to understand this. Again, I am repeating. In this example, this is the chief present in his restaurant, and he will prepare the atoms present in the menu card, and he knows already which atoms to be prepared. This is called as early binding. Whereas, if suppose he is going to participate in a competition, for example, master chief, and in this competition he don't know already which atom to be prepared. So this is called as late binding. This is called as late binding. Now let's see what is early binding and late binding. Before that, binding refers to the process of converting identifier such as variable and performance names into addresses. Binding refers to the process of converting identifiers such as variables and methods into addresses. Binding is done for each variable and function. Keep in mind, binding is done for each variable and function. For function, it means that matching the call. For function, it means that matching the call. Which method to be called, that is called as matching the call with the right function definition by the compiler. Or in simple words, to decide which method to be called, it is called as matching the call. It is called matching the call. It takes place either at compile time or at runtime. There are two ways to decide which function to be called. It is first is called as compile time and next is called as runtime. Again, I am repeating. To call the method, there are two ways to decide to which method to be called. First one is compile time and next one is runtime. So again, binding is, there are two bindings, early binding. So how will you achieve early binding? You will achieve early binding with the help of operator overloading, with the help of function overloading. And you achieve late binding with the help of virtual functions. You achieve late binding with the help of virtual functions. Now, let's see the polymorphism. Polymorphism means one form, one thing has many forms. In simple words, it means one thing is used to accomplish multiple things. And this is called as polymorphism. And there are two types of polymorphism. First one is called as compile time polymorphism, and next one, it is achieved with the help of operator overloading and function overloading. Whereas second type of polymorphism is runtime polymorphism, and it is achieved with the help of virtual functions. It is achieved with the help of virtual functions. Next is early binding. Early binding is it is also called as compile time polymorphism. This early binding, it is also called as compile time polymorphism. As the name indicates, compiler directly associate an address to the function call. Compiler will directly associate an address to the function call. It replaces the call with the machine language instruction that tells the mainframe to leave the address of the function. It replaces the call with the machine language instruction that tells the mainframe to leave the address of the function. By default, early binding happens in C++. By default, early binding happens in C++. Keep in mind. Next is late binding. It is also called as runtime polymorphism. It is also called as runtime polymorphism. In this, the compiler adds code that identifies the kind of object at runtime, then matches the call with the right function definition. what will happen in this runtime polymorphism? When your program is in execution, at that time it is decided to which method to be called. Which method to be called. So in other words, the compiler adds code that identifies the kind of object at runtime, then matches the call with the right function. And that's why it is decided at the when your program is in execution. That's why it is called as runtime polymorphism. This can be achieved by declaring a virtual function. Now, next point is virtual function. And to understand this virtual function, you need to understand array binding and late binding. That's why we have just learned late binding and early binding. So late binding you can achieve with the help of virtual function. There is difference between virtual function and virtual base class. Previously we have seen virtual base class. Now we are going to learn about virtual function. This can be achieved by declaring a virtual function. Now we are starting with the virtual function. So next point is virtual functions. A virtual function is a member function which is declared within a base class and is redefined by a derived class. It is called as overridden. Suppose one function is present in class A and same function present in class B, then it is called as overridden. And in other words, it is a virtual function is a member function which is declared with the base class and is redefined by a derived class. When you refer to the derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class version of the function. Virtual functions ensure that the correct function is called for an object. Virtual functions ensure that the correct function is called for an object, regardless of the type of the reference, or pointer used for function call. We are going to learn this with the help of examples so that you will understand all these statements in better way. And to remember it, you need to do the coding. You need to write the code yourself. You to go to this PPTs, you have to understand it, do some paperwork, then only you can remember whatever you learn. They are mainly used to achieve the runtime polymorphism. Keep in mind, virtual functions are used to achieve runtime polymorphism. Functions are declared with a virtual keyword in the base class. Functions are declared with a virtual keyword in the base class. The resolving of function call is done at runtime. The resolving of function call is done at runtime. We are going to learn this with the help of code so that you will understand it in better way. Again, in other words, a virtual function is a member function that we expect to be redefined in the derived classes. When you refer to the derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class version of the function. You will understand this when we do the coding. What is the meaning of this statement? Again, I am repeating. A virtual function is a member function. Keep in mind, it's a member function. You need to make it virtual. How to do that, we are going to learn. That we expect to be redefined in the derived class. Same function will be redefined in the derived class. And when you refer to the derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class version of the function. Now, suppose this is the class A and you have declared the display method inside the class A. This is your class A and you have written display method inside a class A. From this, you have publicly inherited and you have created the class B. This class B is derived class and you have derived it from the class A. And this display method is present over here. Same display method is present over here. Again I am repeating, just understand this diagram. Once you understand this diagram, automatically you can understand the what is exactly the virtual functions. This is our class A. This is our class A. Inside this class A, I have method display. And from this, I have created the class B. And class A is publicly inherited in class B. And again, in this derived class B, I have method display. So display method will be present over here, and it is present over here. Suppose inside the main, I have written the statement like this: A star A. What I have created the pointer of class A. A is the name of the class A, and I have created a pointer of this class A star A. Nothing but I have created the pointer of class A over here. Now, next statement. I have created the object B of class B. So it will look like this. I have created the object B of class B. Object B of class B. Now, if I written the code like this, A is equal to address of B. A is equal to address of B. A is equal to address of B. The B's object address I have the pointer of class A. So it will store the address of B into the pointer A, which is of type class A. Now, if suppose I mention, I have called A arrow display, and this is the way to call the methods once you use the pointers that we have already studied. A arrow display. So here it is, which method to be called, whether it will call to this method which is present in A, or whether it is present in the display method. A display method present in the class B. Now let's see which method to be displayed. So I have created one virtual function demo project already, and this is the code. Is this code visible? Anyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Fine. So I'm going to create the class A. Inside class A, in the public area, I have method void display. Inside the display, I'm going to write something so that you will understand which method is called. So inside display method of class A. Okay. Next, I'm going to create class B. I'm going to create class B, and I have inherited public A. And again, in public area, I'm going to write the same method. with the same signature, number of arguments are same, exactly same method. And I'm going to write inside display of class B. Okay, so just see what we have done over here. We have created two classes, class A and class B. Class A is our base class and class B is our derived class, and this display method is repeated in the derived class, and this is called as overridden of the methods. This is called as method overridden. Same method is overridden inside the class B. Now I am going to create the object of pointer of class A array. I'm going to delete this statement. Then I'm going to create the object of B. I'm going to say here, and A is equal to address of B. A is equal to address of B. Now I'm going to call the method A arrow display. A arrow display. When you use the pointers, you need to use the arrow instead of dot operator to call a method. Keep in mind. And now just see when you compile what will happen. When you compile the code, it shows the 0 error messages and 0 warnings. Now, just see, as I said over here, when you say A arrow display, which method to be called? Whether this display method present in the class A or display method present in the class B. Let's see in the code. I'm going to execute the code and see the output. The output of the code is what? It will show you inside display of class A. It will show you inside display of class A. So which method is called? The method present in the class A is called. Method present in the class A is called. So when we say A is equal to address of B, why display of B is not called? Display method of A is called. Just right now we have seen. Why not this display of B is not called? Here is the concept of early binding and late binding. When we compile the code, compiler keeps ready all the things. When we compile the code, compiler keeps ready all the things. Like he told himself when to jump on which line of the code when function is called. So when you say A is equal to address of B and A arrow display, when early binding is done, compiler doesn't care about the address pointer is holding. It doesn't care about which object's address is held by this pointer. It is happen in the early binding. Again, I am repeating. This is important thing you need to understand so that you will understand this, how this virtual function is called and what is early binding. In early binding, compiler doesn't care about the address pointer is holding, and this A is holding the address of B. So it will not take care about this B's address right now in early binding. So simply because of this, the display method present in the class A will get executed. Display method present in the class A will get executed. and this is called as early binding. This is called as early binding. What compiler does? A is of class A, so display of A class will be called. What compiler simply does? A is a class of A, so display of A class will be called. But we want to give preference to the address. Address is in the pointer. If suppose we want to give the preferences to the address in the pointer. In other words, now I want to call the method present in the class B. I want to call the method present in the class B. So how should I call it? In this case, we need late binding. In this case, we need late binding. So just add virtual keyword in front of the function in the base class. So just add virtual keyword in front of the function in the base class. Once you add virtual keyword in front of the function, that function becomes the virtual function. That function act as a or considered as a virtual function. So I'm going to demonstrate this with the help of code. Now I want to call this display present in the B, and I'm going to make this as a virtual function. Virtual void display, and this is your virtual function. Your virtual function, and this is the way to create the virtual function. Now, whatever object of A, consider the address of that object will be considered while calling the method. Now, once I mention virtual here, and I have written the code like this: A object I have created star A, I have created object of B, and I have kept the object of B, address of object B into the pointer A, and now I am going to call A arrow display. First of all, compile the code. So there are 0 errors, 0 warnings. So there is no error in the code, and I am going to execute it. Now see what is out. Inside display of class B. Inside display of class B. So previously the output was inside display of class A, and now output is inside display of class B. And why? Because we have made this virtual function in the base class, because we have mentioned virtual function in the base class, and this is called as virtual function. This is called as virtual function. So what we have seen in today's session: first we have seen virtual base class, then we have seen early binding and late binding, and now just we have seen virtual function, how to create it, what is the importance of it, and in which situation you need to create the virtual function. If you are having the situation like this, you need to use the virtual function. Now these are some of the rules you need to remember while creating the virtual functions. Virtual functions cannot be static. Keep in mind, the virtual functions cannot be static, and also cannot be frame functions. Keep in mind, it cannot be static as well as frame function. Virtual functions should be accessed using the pointer or reference of the base class type. These virtual functions should be accessed using the pointer or reference of the base class type. That's why we have used the pointers while accessing the display method. And with the help of this, we can achieve the runtime polymorphism. With the help of this, you can achieve runtime polymorphism. At the time of your program is in execution, at that time it is decided which method to be called, and it is called as runtime polymorphism. The prototype of virtual function should be same in the base as well as derived class. Prototype nothing but the signature of the method. It must be same in base as well as derived class. There are always defined in the base class and overridden in the derived class. It is not mandatory for derived class to override or redefine the virtual function. In that case, base class version of the function is used. There is no compulsion to override that particular function that you have made virtual. Class may have virtual destructor, but it cannot have a virtual constructor. You can have a destructor, but you cannot have a constructor. It is just for your information. So runtime polymorphism is achieved only through a pointer or reference of the base class type. Keep in mind, runtime polymorphism can be achieved only through a pointer of the base class type. Also, a base class pointer can point to the object of base class as well as to the object of the derived class. This base class pointer can point to the base class as well as derived class. Late binding is done in accordance with the content of the pointer, and early binding is done according to the type of